So, Hassan, one of the things that I want to give as a little bit of a background here is to talk a little bit about the history. And routers that we use today, we're so used to calling something a router or a firewall. And in reality, if we step back in time just a little bit, back in the 80s, when I used to be in the office in the ancient days before wheels were invented and that sort of thing, we it was not uncommon. In fact, it was very common to have a desktop computer that had a real address out on the internet. And it's because there were not that many people on the internet at the time. And part of the reason for that is because something you're so familiar with and so used to today, which is the whole idea of NAT or network address translation,
Relation.
did not exist. In fact, NAT was started to appear in some of the discussions to formulate a standard in the 1993 or 1994 timeframe, believe it or not. And probably the first folks that introduced it as an early commercial implementation that really wasn't yet a standard was in late 1994. Cisco introduced the concept
That
of NAT.
makes
And
sense.
so, somewhere around 1996, I'm going to say, the whole idea of NAT came into being. And so the general idea, well, there were a couple of reasons for it. First of all, there was a firewalling reason for it. We didn't really worry in the early days about any kind of subversive things going on the internet because there weren't that many people on the internet. And certainly back in the 80s, we really didn't have the concept of people being out there that were
Malicious.
regular users even. So, as you know, people are really used to the fact that, hey, I get this retail router and I fire this thing up and it's got an address of 192.168.1. Something. And as it turns out, the whole 192.168.0.0 on up to 192.168.255.255 is one of those huge address ranges. It's a 16-bit address range, so it has 65,535 addresses in it. And then there's the second address range, which is the 172.16.0.0 range that goes up to 172.31.255.255. And that's got like a million or so addresses in its range. And then we've got the 10.0.0.0 all the way to 10.255.255.255, and that thing's got like 16 million or so addresses in it. So all those addresses are referred to as a private address range because you'll never find anything publicly on the internet that has that address range. And part of the reason for that is because the whole NAT protocol and how routers are built around the fact that these private address ranges are duplicated all over at companies and people's home labs and people's houses and all that sort of thing. So, one of the original ideas behind the idea of having NAT was that we wanted to have the ability to provide for more address space in a world where people were coming onto the public internet very rapidly. And so it was using up the address range in what we know today as the IP version 4 address range. And so what NAT did is, if you have 10 devices at your house and I have 10 devices at my house, then we're only really using one public address because your router gets a WAN address or an address on the wide area network. And then behind that, you have this network address translation that has a bunch of small addresses or a bunch of addresses in a private range. So basically how it works is if I'm sitting on a desktop computer and I go to say Microsoft.com, I go to a particular address and I reach Microsoft.com. And when I make that request to go to Microsoft.com from my desktop computer might be something like 192.168.1.10 or something. And what'll happen is I'm going out and I'm reaching out to the address on the public internet for Microsoft.com. Well, I get to that web page, but that web server has to know how to get back to me. Well, when that request for that information leaves my network and it leaves my router, part of the NAT protocol is to encapsulate my wide area network address and also my local address, that 192.168.1.10, otherwise known as a private address, inside of that packet. So what happens is that when Microsoft.com says, well, here's your web page, and it goes to send it back to me, it can look inside of that encapsulated communication and send it back to my WAN address. When my router gets that, it breaks it down further and says, hey, this thing out in a private address behind this router at 192.168.1.10 is the real place that I should be returning this information. And that's basically how things function. So we started in the mid-90s calling all of these things routers or firewalls. And basically what we meant a device that implements network address translation to accomplish exactly what I was talking about here.
Makes sense.
So a little bit further down the road, they started to have routers do more sophisticated functions. They could do firewalling functions because basically from the beginning, it really meant that nothing on the internet could reach you unless you had reached out to it first. And so there were many situations where you might want to have something reach out and touch you remotely, hence the whole idea of the self-hosted applications and technologies that we have today, like port forwarding and reverse proxy and all that sort of business. Well, the way that ended up coming about was the need to be able to provide access when maybe I didn't own a lot of public addresses. Because in the beginning, some of the very large companies held very large address spaces, like they held multiple Class A networks. A Class A network is where you have maybe the first number, 10, and then the last three numbers are allowed to change to any number. And a Class A network has 16.7 million addresses in its address space. Well, there were lots of public companies out there like IBM and Digital Equipment Corporation and Hewlett-Packard and Xerox that held not only one, but sometimes many of those Class A address spaces. And that's even the case today because back in the beginning, they got those addresses from the Internet Address Authority, IANA, and they hadn't given them up since. And so right now we're in a position where we need more addresses. That's partway solved through NAT. The other way it's solved is by going to IP version 6. Yes.
Yep.
Yes, exactly. So routers got to be kind of interesting in a way. The first routers that were from companies like Cisco, they had a command line to institute a lot of the more complex things that companies would need. And then later on, they started to have a graphical user interface to do a lot of the things that they do. Go click on your settings, the gear down there, and then go ahead and go over to the under policy engine there on the left-hand side You got that little thing with the 4 blocks on it. Yeah, a little up. There you go. So originally, once they went to a GUI, a lot of times your firewall rules, which said what traffic was allowed to go where, were categorized according to things like LAN in and LAN out and WAN in and WAN out, perhaps a guest network, perhaps a difference in firewall rules between IPv4 and IPv6. And that's the way it had always been done. And so we always had firewall rules where in the list of rules at the very top, you always had the, I guess, the most permissive rules, the allow rules. And then as you went down in the list, you could have less permissive rules, otherwise known as the block rules. And so rules are evaluated from top to bottom, and as soon as you meet the qualification for a particular rule, it dumps out and does that rule and then doesn't come back. So basically what will end up happening with firewall rules is that they get a very specific hierarchy associated with them. Now where it gets really interesting is the fact that there's a lot of things about firewall rules. Like, for example, just because I'm allowed to communicate maybe over to this other network, you also have the consideration, is that other network allowed to communicate back to me? And that's where we had to learn things like allow established or related traffic, which basically meant that I want to be able to go over to this other network or maybe this other VLAN, which is a different address range. But then am I allowed to send my responses, or is that network allowed to send the responses from that communication back? And so a lot of this became pretty confusing. Well, that wasn't really a huge problem because, well, most firewall rules were being done by network managers, and they were being done to a minimum because there wasn't a lot of advanced firewall management taking place. Well, in the last couple of years, that's really changed because firewall management now has really gained a huge amount of granularity. And that granularity might be controlling not only what traffic is allowed back and forth, but what type of traffic. So we can do things like DPI, which is deep packet inspection. And deep packet inspection can look at the contents of a data packet and determine what type of communication. Like, well, this packet, when I look into it, it looks like it is maybe communication to Facebook, you know? And so you then, since you can do deep packet inspection, you can now build firewall rules that might apply to what do I want to do with Facebook traffic? Do I want to allow it? Do I want to allow it only during certain hours? Do I want to allow it only to certain networks or to certain people? So you can really provide a lot of granularity. Right. So here on this page that you're looking at, we've got this whole concept of upgrade to the new Zone Based Firewall concept. And that's something I did a video on here not long ago. And what the Zone Based Firewall does for you is it really simplifies how you do that firewall management. And here we have almost no firewall rules at all. The firewall rules that we have are basically allow established related traffic, and then we have the block IoT VLAN from the main LAN. And so aside from that, you're really not doing any, quote, creative firewall rules, and that makes your conversion to the new zone-based firewall very simple. So is Ubiquiti the only company out there starting to do zone-based firewalls? And the answer to that is absolutely not. Cisco also has zone-based firewalls. And part of the reason to do zone based firewalls is that instead of having a large number of rules, you can actually have your rules defined by zones and allow the zones to work for you so that your definitions end up being enforced by the zones and you end up having far fewer rules. And as an example, prior to when I did my upgrade on my Ubiquiti firewall from the traditional setup that you see here with rules and went over to the zone based firewall, I had something like, I guess around 25 or 30 rules, and I ended up with like 6 in the end, and yet I'm doing the exact same thing. And that's because I'm having the zone based firewall work for me.
That definitely sounds a lot simpler, easier to understand, because I definitely looking at, my own firewall setup. It definitely seems a bit confusing to me because there's a lot of repeated rules for different things, making it a bit difficult to understand, you know.
Sure, sure.
The ZBF that you described definitely sounds a lot simpler. I've definitely tried on my own to get a grasp, and even being someone who's, a CCNA holder, you don't necessarily understand fully what all those rules mean.
Yeah, and I think part of the reason for that is because when you've always worked with the traditional firewall rules, that's straightforward to you. Trying to teach it to somebody else isn't always the easiest thing, but it's really difficult to move towards a zone based firewall for the simple reason that even though it is easier, it is a change of the way that you have to think, and that can be challenging. So there can be some learning curve to just basically understanding this really simple thing. So, in advance of trying to do anything like this, you basically want to go down and do
Full
a
backup.
complete backup. And the way you do that is you go over to your control plane.
Definitely a best practices situation here. Okay.
Right. So in your control plane, if you click backups, this backup that you see here is an entire system backup of the entire console. And that would mean Unifi OS. It would also mean the
Rules, settings.
rules, settings, switches, all that. But even if you had something like Unifi Protect, which you do, it would back up Unifi Protect. Same if you had Unifi Access. Same if you had Unifi Talk. So you notice that it's set up to do a weekly backup, but you can always
Yes.
go over here and click backup now. Your last backup was on December 31st. So backup now, we'll just go ahead and do another backup right now. And so you always have the opportunity to download a backup that it does. It says it's created it that simply. Mine takes a little bit longer because I've got a lot more stuff on my network. And go ahead and click download. And what that will do is it will go ahead and download a file to your local machine. And that will be a file that has in the file name Unifi OS backup, as you see there. And that's because it's backing up the entire Unifi OS, which includes not only the network, but all the applications under the network as well. So if you did this firewall conversion and you didn't like something about it, you could go back to this backup and restore it and would have put it back exactly the way it is today.
Perfect.
So that being said, that's not the only backup that we have in the world of Ubiquiti. The other thing that we have is we are in the network program right now. If you click System, which is one option up there from your control panel on the left-hand margin, if you click System, you notice that it has backups here too. Click that backup. Now this backup is only a backup for the network and nothing else. and that's because we're in the network program. So there are times when maybe you don't want to back up all of Unifi OS, the Unifi OS users and so on, but you just want to back up your network configuration itself. And that might even be just more applicable here, but it's nice to have both. And whenever I do backups, I do both types of backups as well.
Same.
So if you
That's
click,
my mindset.
right, so if you click download here, you get another pop-up option which says settings only, and if you click on that, it says last 7 days, last 30 days, and so on. I generally pick last 7 days, and what that does is it gets a little bit of a history for things like your DHCP address leases, and they get incorporated into the backup, which can be valuable if you've had new things popping on your network. You might want to have that information be a historical part of that backup.
Absolutely.
So go ahead and click download, and that'll take just a minute, and it will say fetching there. Sometimes this takes a long time. For whatever reason, I've discovered in the Ubiquiti world, in the Unifi world, I should say, in that product line, that the longer that you have a Unifi router running, the longer it takes for that backup to run. And yours came up pretty quick. Mine's taken as long as like 20 minutes to come back. And
Wow.
And that's probably because, I've got several hundred nodes and, 8 or 9 switches and I don't know, all kinds of stuff out there. All right, so now we have a backup of both the network and we also have a backup of Unifi OS.
Yep.
So let's go back to under that policy engine there and hit that 4 block icon, that second one you see there. One up from the system you're on there. Yeah, there you go. And we notice the only thing you really have here is allow established related rules. Now, just for fun, you see where it says LAN and it says there's 8 LAN rules highlighted? And if you
Yes.
go to the left there where it says all, that will get all rules, and that'll show you every rule that you have on the firewall. So generally, but not entirely true, if you see a lock on it, it's probably a pre-established rule. Now that's not necessarily the case that it's a built-in rule, because you'll also see the lock here if you happen to be looking at a rule that was created somewhere else. For example, the allow established related traffic was a rule that we created on your network, but we created it for LAN in, and because we're looking at all, it's showing us the lock next to it for that reason. And the lock typically means, yeah, you can look at this, but you can't modify it from here. And that's another thing that was pretty complicated, because it's like, well, I have to look at all this stuff. How do I know what I'm doing? And if you scroll down, you'll get to see all these different rules. And there's a lot of them here. But you notice the only ones that you can change the order of happen to be allow established related traffic and block IoT from main LAN. And the reason for that is because those are the user established firewall rules. You can modify them, you can delete them, you can change the order of them. The ones with the locks you cannot, and those are the built-in rules that basically handle the care and feeding of the router. So this is a really good time to look at something else. Let's go ahead and click on where it says networks up there on the left-hand side there. Yeah, there you go. So under networks, let's just go ahead and click on your main network, which you've called the cave. It's VLAN 1. And let me make a comment here. So I made a video not too long ago talking about some restrictions on VLAN 1 when it came to VPNs that I noticed on the Cloud Gateway Fiber, which I don't know if they're going to expand on or not. But some people in the industry, even though when you first set up your Ubiquiti router, it sets up a default VLAN 1 network, a lot of the people in the industry consider it to be a best practice to not really use 192.168.1 because everybody else uses 192.168.1. Well, who cares if it's a private address range? Well, here's where you care. If you want to connect to somebody else's network and you're going to use a VPN, the VPN that you're using cannot match the address range of a remote network you're connecting to. So you couldn't connect to another 192.168.1 network, and that's the reason why people tend to choose some more obscure ranges like 172.16.10 dot whatever, okay?
And I've often had that problem. I won't
Right.
deny that.
So that's the pull it out of the back there and decide to do that. The other thing is that some professionals tend to also not want to use VLAN 1 because in the industry they'll teach you that VLAN 1 is the management VLAN and you should leave it alone for managing your infrastructure. And you should create another VLAN, VLAN 2, 5, 10, whatever number you want to put all your users, even your trusted users, okay? So imagine this for a second. It's kind of the basics of a network. If we have VLANs, which are just other address ranges or isolated networks, why do we have VLANs? Because in IP version 4, it's all broadcast based. So a network that might have, say, 50 devices on it would be much faster than a network with 400 devices on it. And part of the reason for that is because it's like walking into a room with 10 people talking. You can probably catch most of the conversations. Whereas if you walk into a room with 200 people talking, chances are all it is noise. So setting up a network with a smaller number of systems is generally a good idea for performance, but that's not really why people use VLANs. People use VLANs primarily for isolating traffic for security reasons, but it can also be for performance reasons. So that being said, I kind of tend to look at your basic network and say, hey, VLAN 1 is maybe your infrastructure VLAN that's used as your management VLAN. And then maybe pick another VLAN number for your main network and consider that to be kind of the trusted network where all your trusted devices fall. And then you might have another network that would be like your IoT network. And here you've got IoT VLAN 2. And a real good example of what that might be used for is there might be a number of untrusted devices. So a prime example of an untrusted device might be something like a smart speaker, maybe a Amazon Echo, or maybe something like a Google Home Assistant, or maybe even a camera.
Google Home, SwitchBot Mini, something like that.
Anything like that. And a part of the reason for that is because you didn't write the code for those devices, and those devices might need to phone home, and you might not want that kind of traffic moving on your main trusted network. And so some people might say, why? And the biggest answer to that is because one of the biggest ways to subvert network security is by not having a more confined attack vector. And a broader attack vector means more places to have to control and more places to have to watch in order to protect your network. And one of the favorite targets, if you will, is something called transitive networks. So a transitive network or a transitive system, a transitive server, is a server or a device, and that can even be a camera. Consider a camera to be a server. Somebody, if that camera's firmware was, say, made in China, and you have it running on your trusted network, somebody from China might be able to connect into that camera, and then from there they might be able to reach out to other things on your network. That's called transitive access. So one of the reasons to put things on other firewalls, on other VLANs, is to be able to cut down on the situations where we have a broader threat surface, and we do that by segmenting things off that we consider to be untrusted devices. Okay, so here you
I
clicked
love the
on
security consciousness in that statement.
right. So here you clicked on the cave, and over in the right-hand side there, we're looking at your VLAN 1. And one of the things that's kind of interesting about that is if you scroll down on that a bit, I'm not sure exactly where they've stuck it now because they keep changing that. The window on the right side there. The window on the right side, yeah. Scroll down there a little bit. I'm looking for something. Oh yeah. Go up a little bit from there. Okay, so this is probably not a good example because VLAN 1 is a little bit more restricted than other ones. Go ahead and X off of that one, and let's click on your IoT VLAN because it can illustrate the issue a little bit more closely. Go ahead and hit the X on that window of the cave. Yeah, and go ahead and bring up your IoT VLAN. Yeah, the second one down there. Go ahead and click on it. Okay, and you can stop right there. So you notice there's one of the criticisms I've gotten about Ubiquiti as a network provider is that when you create a VLAN, by default, every VLAN can talk to every other VLAN unless you put firewall rules in place that prevent that communication. And
I like that.
And that's always
like
been
that.
the way that Ubiquiti does it. But a lot of people consider that to be very backwards. And the reason is because Cisco has always taken the, quote, more secure approach.
Security first
And
approach.
their approach has been that when you create a VLAN, by default, it has access to nothing. So in the last couple of versions of the Unified Network program, I think it popped up in version 9. We're at version 10 now. If you look here pretty close to where you've got your red mouse pointer, there's a thing there that says isolate network.
Yep.
Well, so it used to be that when you created a network, by default, it wasn't isolated. It could access everything else. Now it's possible to change the global setting so that when you do create a new network, it goes ahead and isolates everything else. Or like you have here, when you created this network previously, it did provide access to everything. So we added firewall rules to restrict that access. Well, you could turn around and put isolate network and it would isolate everything from it. And then you'd have to add firewall rules back in to provide access to it. So just saying that's just two different ways of doing things, two different ways to think about how you are going to do things. And there's your windows popping up telling us stuff. So the other thing you've got here is the allow internet access. And so a lot of people might have like PoE cameras, power over Ethernet cameras that do RTSP. And if their cameras are completely private to their network, they might see no reason for those cameras to have internet access. So you could create a VLAN that had nothing but cameras on it, and you might uncheck the allow internet access, and then that VLAN for the cameras might not be allowed to connect to the internet, but other networks might be allowed to connect to it to see your cameras. So this all kind of depends on how you design things. So here I'm thinking, main network where trusted things are, IoT VLAN where you have untrusted things, and some people would just call that an untrusted network, maybe potentially a camera VLAN. And then you have one down here called self-hosted. I like to kind of refer to that as a DMZ, a demilitarized zone. So the idea behind that is that maybe you have things with Nginx Proxy Manager, like maybe Rocket Chat. and you're serving that out through the internet, and people are connecting to you. And when they connect to you, they go through Nginx Proxy Manager that contacts the local server, and therefore they can connect to this application and get service from it, even though they're not on your network, they're on the bigger public internet. So the beauty behind that is that now we can have public self-hosted applications, which is kind of the whole purpose of my channel. I talk about that, but I talk about that in the context of a infrastructure. So the thing is, if all of those self-hosted apps fall on their own VLAN, sort of a demilitarized zone, or what you called here a self-hosted VLAN, the beauty behind that is that self-hosted VLAN might not have any privilege to get to your trusted LAN. And so, God forbid, if somebody were able to break out of one of those applications, they would not be on your trusted network, nor would they be able to gain access to it. So again, by firewalling things off from one another, in this case VLAN isolation, we increase security and we decrease our threat surface. Okay?
Makes sense.
All right. So, are you ready to go over to the zone-based firewall and learn how that operates over here, since we have a backup of both your Unifi OS and your Unifi network, and God forbid, should everything absolutely detonate, you'll still be able to come back?
I'm ready for a simpler time with this.
Okay, well, if this really screws up, I know a good consultant that only charges like $500 an hour.
Jeez.
Yeah, there you go.
Keep that in mind.
Yeah. Okay, so go ahead and go back to your policy engine over there. That underneath the 4 blocks we were on under policy engine on the left-hand side. Yeah, there you go. All right, so up there at the top, and we go ahead and go back to LAN, by the way, over there in that list where it says all, and in internet it says it has 34 rules, and LAN has 8 rules. So most of the people that do learn how to do these traditional firewalls always learn to use LAN in rules, because those are the predominant rules that we usually use. And the other thing they learn to use is maybe WAN in and sometimes WAN out rules. But this gets complicated. And really, Ubiquiti had the concept here between simple rules and advanced rules. You can see that over on the right-hand side. It really didn't do anything to make them simpler, to tell you the truth. But we don't have very many rules. Like I said, the only one you have is allow established related traffic. And right now you have blocked the IoT from the main LAN, and we're not even really blocking your self-hosted VLAN from your main LAN. So let's go ahead and where it says upgrade to the new zone-based firewall, simplify firewall management, and reduce complexity, and they aren't kidding. So go ahead and click to upgrade. This will take probably about 30 seconds. It provides a little bit of a picture there, and that's it. So we have done the complete conversion. The conversion is totally done. Okay?
What?
Yep, that's it. That's all there is. Okay, so you got a picture here at the top, and this picture is showing that you have kind of a zone called the VPN zone. You have a zone called the DMZ zone. You have a zone called the external zone. So what are these things? Well, VPN zone would contain things like your VPN servers. So if you had like a firewall, if you had like a WireGuard or a Open VPN server, which Ubiquiti supports, they would naturally fall into the VPN zone. And then DMZ is where your public servers should fall. And when I say public servers, I would mean maybe if your self-hosted VPN is that VPN, then you'd want to put it in the DMZ zone, because the DMZ zone would be this sort of isolated zone. And then the external zone, well, that's basically anything on the internet, anything outside the WAN, right? And
Right.
then gateway is just yourself, so that's really not all that meaningful because it's just really the gateway, so to speak. And then the internal zone is basically right now where all the networks are. So when you do this conversion, if you look at this part down here, it says zone. I'm kind of circling it with my cursor on this side. I know you're sharing over here, but you got the zone names, internal, external, gateway, VPN, hotspots, another one, and then DMZ. Okay. So after the conversion, it sticks everything in the internal zone. So you had 3 VLANs. The cave, which is VLAN 1, your primary network, it's in the internal zone. IoT VLAN, it's also in the internal zone. And then self-hosted, it's actually in the internal zone also. And then for external, we have Internet 1 and Internet 2. You're running a UDM Pro Max, and the UDM Pro Max has by default 2 WAN connectors. And so both of those are placed in the external zone because those are the things that go out to the external internet. Gateway, we don't have anything in here. If we just hover over the top of it, you can hover over the top of it there. I guess it has a little eye there that tells you what it is, right?
Alrighty. Gateway.
Yeah, gateway there. Further down, the one in the list there. Yeah. Further up, where it says zone names. Yeah, go to where it says gateway. Further down, left. There we go.
Yep.
So basically, it says that's the zone used for the gateway itself, and that's really not anything all that meaningful. Okay. So then we've
Makes
got
sense.
VPNs. Well, you got a VPN that's called the Hassan's UI Identity WireGuard server, and that's one for your Unifi Identity. You got another one that you just call WireGuard UDM Pro, which is a straight up WireGuard. And I'm not sure what this last one is here, but it's another VPN. And then we don't have anything in the hotspot zone, and we don't have anything in the DMZ zone. So the reason that Ubiquiti does this conversion in the way they're doing it is they don't mean to do this in a way that makes any sense. In other words, after we did the conversion, we don't really end up with something what I consider all that usable. Their real purpose behind doing it was to do a conversion that wouldn't break you. And so it's designed not to break anybody. And so here again, we have this list of these zones. And let's talk about something really strategic here. So the internal zone has the cave, the IoT VLAN, and self-hosted. What that means by default after the conversion is it means that these 3 networks are allowed to communicate with each other openly. All right? Now, I know we have a firewall rule that prevents some of that communication, but in general, that's kind of how they're defined. Now, some people might disagree with what I do because there's not one way to use zone-based firewalls, but I'm going to give you my own take on it. So
Okay.
they lumped all of the networks into the internal zone, which is just fine, but not necessarily all that practical. So what you really want is we really want to put your self-hosted network in the DMZ from my description earlier, okay? So if I click DMZ
Very
and I
interesting.
go say select and I check off the self-hosted, we're going to assume that would be where maybe your Jitsi server would be or
Right.
something like a Discord
Public
server.
services that I want to share.
Right. So then I do an OK, and it gives you this big glaring warning: create zones for additional segmentation, blah blah blah. So if I say apply changes, it's going to come up and say, hey, move this network to that zone. Please proceed with caution and view the policies applied to this zone to ensure traffic from devices is not accidentally blocked. Which I can tell you right now, it definitely will be. So we'll go ahead and do that, and we're going to look at what that blocked almost immediately. So what it did was it moved self-hosted from the internal zone and it pushed it down here into the DMZ zone. All right, so now before we go much further, we're going to come down here and look at something really kind of cool. So what we got here is we have a matrix, and this matrix has a the x-coordinate, the x-axis, and the y-axis. The x-axis is the destination, and the y-axis is the source. So for example, if you're in the internal zone and you're going to the external zone, all traffic is allowed. If you're going from the internal zone to the gateway, all traffic is allowed. Basically, everything's allowed from the internal zone to all the other zones, okay?
Makes sense.
On a situation where you might be in the DMZ, if that's your source zone, and that's where self-hosted is right now, if you're in the DMZ, then if you're trying to go to the hotspot, you can't get there because it's blocked. And the DMZ can't get to other things in the DMZ because it's basically blocked also. And you're going to go, what the heck? Well, it's a really isolated network. Now, here's the cool thing about this. So we have these things for like established related traffic. And this one, do this type of thing here. If we were to click on something like internal to internal, which is where everything is right now, here's your two firewall rules that moved across, okay? And if I was to go up here and click on all policies, which there's 96, you're going to go, 96? Where'd all this come from? Because what they end up doing is we have allow, establish, related, we have the block, and then we have all these built-in rules. And then we have some allow returns and that sort of thing down here. So we got a whole myriad of stuff. Well, the other thing you can do, these built-in zones are one thing. You can also create a zone. And so I like to create a zone called the IoT zone. And I might potentially have more than one IoT network, okay? And so I created my IoT zone, and I can turn around and say, I want to select my IoT VLAN right now to go in my IoT zone. Right. And now, oops, stay, apply changes, yes, proceed, after reading the standard disclaimer. So the problem with this is now, if we start, I created this zone, and by default, a zone can only communicate to other networks in its zone when you create a custom zone. So now if I go from the internal zone to the IoT zone, scroll over here, everything's blocked. You can't get to the IoT zone can't get to you. Well, that's not what I wanted at all, okay? So what I can do is I can say from the internal zone being the source, and the IoT zone being the destination, I can say create myself a policy. And I can say allow internal zone to IoT. And so if the source zone is internal, which is what we have here, any device on the internal zone, meaning any network, any device, and any port should not block, it should allow, and the destination zone is the IoT zone, and it should allow return traffic. So now when I apply that policy, what ends up happening is that now when we look at this matrix here, we can see that when we start in the internal zone and we go to the IoT zone, we got all the traffic allowed. And if we click on it, you can see that right there.
Huh. Okay.
Now, remember our old rules that we had here? The old ones that we had created, the
allow
Allow established
yeah, the
related
two
traffic.
user rules.
So,
Yeah.
right. And that was the one that we had up here in the see where it has this thing here. It says the match network is no longer present because those were our custom rules we created before the conversion. And they survived the conversion. What they didn't survive is they didn't survive me yanking the IoT zone out of internal and sticking it down here. So these rules aren't applicable anymore, and that's why they're grayed out. So if I click on that grayed out rule, I don't need it anymore. I just remove it because it doesn't do anything. It's broken, as is this one broken. So I go down here and I remove it also. Now, so the only thing we really have here is we created this one that says if we start at the internal zone, we can go to the IoT zone. But what if we start at the IoT zone and we go to the internal zone? And here it says that we are allowing the internal zone to IoT with return traffic, but all traffic is blocked otherwise. There's no allow rule that says that the internal zone or the IoT zone is allowed to go to the internal zone as a destination, which is exactly what we want. So you see how that really streamlined how that rule was set up?
As simple as 10 to 15 seconds. Yes.
Yeah. So then what about self-hosted? What might we want to have there? Well, self-hosted's in its own little DMZ. So let's see. If we start out at the DMZ, or actually if we start out at internal and we try to go to DMZ, it says all traffic is allowed. Well, that's good. That's probably what we want. If we scroll down, it just says allow all traffic. So that's fine.
Right.
Internal can go to DMZ. But what about DMZ to internal? Well, we click that and it says allow all return traffic, only return traffic. That means traffic that initiated on another network, but block everything else. And that's exactly what we wanted.
Absolutely.
So now, before we did this conversion, your self-hosted network wasn't blocked from your internal network. Now it is. But internal is allowed to go to DMZ, and internal is also allowed to go to IoT. So now you're seeing where the power is. You just look at these things, and if you want to see the rules for any particular area, you can see what's going on. So as a really good example, let's say your source was the IoT network, and you wanted to go to a VPN. Well, it's blocked. There's no rule that says the IoT network is allowed to use a VPN at all, which is probably appropriate if you think about it. And then, likewise, other things
I
like,
absolutely agree.
like the hotspot, which is for a hotspot guest network. But let's look at like DMZ is not allowed to go back to the IoT network. That's probably appropriate. And the IoT network is not allowed to go to the DMZ network. So these two zones, I keep saying network, I should say zones. So those two zones are also isolated from each other. And see, the only custom zone we created here was IoT. And we can create other zones if we want to. But you see how the zones do the heavy lifting, and then the rules within do the minor granular types of things. So here's where it gets really interesting. Suppose I want to have something starting at the IoT zone and allow it to communicate to the internal zone. Well, why in the world would I want to do that? Well, an example is I might have a device on my IoT zone that needs to initiate connection with your habitat. It's not that your habitat elevation hub needs to reach out to the IoT network, because it can do that today. But let's just say we had something on the IoT network that had to initiate communication with the habitat. It couldn't do that today because that'd be blocked, right?
Right.
So what you can do is you can create a policy, and we can say, allow I don't know what we'd call it. We can say allow, XXX access to habitat, because I don't know what to call it, okay? So the source zone would be the IoT, and you could say just this particular device. What device? Select the device, and then I can go off here and search for habitat.
So then what we would call it is allow IoT access to habitat.
Well, but it's going to be one specific thing, because the source might be the.
I see. This is
Well,
part of the
I didn't mean to
granularity.
say. I didn't mean to say habitat. I kind of messed up there. Habitat's going to be our target. So we're going to select something here, and we got to find something on the IoT network, and I don't know what it is, but let's just
Harmony.
Yeah, okay. The Harmony is on the IoT network, so we'll go ahead and select it. So it basically says on the IoT network, if we're starting there, the Harmony API, and probably you don't want this because it doesn't need to do this, but let's just make believe it needed to, okay? We're going to say on the IoT network, the Harmony API is allowed to talk to the internal zone if and only if it is going to talk to a particular device. And so that device might be something of a specific IP. Let's just say that it was like, I don't know, 192.168.1.10. Let's say that was just the address of your habitat, okay? And we did that. Then this thing, oh yeah, you have to say add the address, and then you say add the policy. So then you would basically have a policy that would say allow this thing, this Harmony API. So you could say allow, be very specific. We just say allow Harmony-API, allow Harmony API access to the habitat. And although that network is normally blocked, now if I say on the IoT network and I go to the internal network and I click on it, there is a rule, and that rule is before those other rules, and it basically says, hey, oh, I have a block rule. That's not supposed to be block. It's supposed to be allow, right? We want to allow that. So it can basically say, I want to allow specifically this device on this zone access to this device there, where normally all of that is blocked. And again, the allow rules always before the block rule. So if it doesn't meet that qualification and it doesn't meet this qualification, then it gets blocked.
Makes sense. Okay.
So that's pretty neat.
And this is, and again, just to be clear, this is device specific.
Well, it can be anything really. So it could have been device specific. It can be network specific. It could be IP specific. It could be MAC address specific. It could be a group of devices, So you can really get very granular here. These rules are different. And what's neat about them is in the old system, we didn't have all these neat things where you could click them off quite the same way. And now they're just much easier. So I don't want this rule. I say remove, and boom, it goes away, and it's as easy as that. So, this is kind of how you can do things. So let's say you're doing something on your network, and you've got something in the IoT zone, and you're working on that IoT zone, and for whatever reason you want to access something on your desktop that's back in the internal zone. Well, you can provide a temporary firewall rule to allow that, and then it can go ahead and allow that, and then maybe when you're done doing whatever you do, you take that rule away. So, all this is very doable. But that right there is basically how the configuration works. Since your network is very simple, there wasn't really much of anything we needed to do to establish that configuration. Okay, so that being the case, we have completed our conversion from the legacy firewall to the zone based firewall, otherwise known as the ZBF. And what do you think about this, Hassan? Do you think it's pretty straightforward? Do you have any questions? What are your thoughts?
My thoughts are it's definitely more simplified than the previous firewall implementation. Um, though it's definitely going to take a little bit for me personally to get everything down 100%. I feel much more confident than I did with the previous rules. It definitely, it definitely seemed confusing having so many different iterations of the same rule for different devices, different services. Your explanation has, definitely been well in depth and easy to understand. With easy to understand and definitely something that I can grasp with my personal learning method.
Yeah, and I think the other thing that a lot of people don't really realize is the other thing that you gain yourself as a result of having gone to the new configuration is that you also have object management. So, with object management, which comes along with the zone based firewall, you can then start to do what they say in this diagram up here. You can use object oriented networking, which is basically you can create a rule for this, and this happens under this particular situation. And that means you can block types of traffic and you can have routes and you can have quality of service connections. So it does a whole variety of things, and you can make that
So
apply
many
to
options.
yeah, you can make that apply to things. And so that what this is like, and I know that I've spent a little bit of time with you on working on the alarm manager, and I've had a few videos on the alarm manager. What this lets you do is this lets you do almost the equivalent of alarm manager, but rather than being alarms, they end up kind of being rules for the ways you do things. The other thing that we have besides object-oriented networking, which would be an entire video for sure, is if we click on the first icon over here for the policy table. So it used to be that we went to a whole bunch of different menus in order to see all of our policies. And what they did in this newer version is you could go down here in this list and, for example, you can click on ACL rules. And we don't have any ACL rules, so it doesn't do anything. Likewise, you can click on DNS records because we can have our own DNS A records and DNS CNAME records. That is local DNS records that are on the Unifi Gateway. I'm using a Pi-hole and you're using a Pi-hole right now because of some other granularity, but they do have this. And for a lot of people, this is a really nice feature. And then you see here that down here, firewall is actually highlighted. It's not grayed out. So if we click on firewall, it's going to give us all of those firewall rules that we're looking at with the zone-based firewall. And so this is kind of a hodgepodge. It's a place where they're all dropped. And then we've got NAT rules, and of course the NAT rules are going to be, your network address translation rules for certain things happening, and there's going to be a couple of what they call masquerade rules, which is kind of an advanced concept. And then we have a whole mess of port forwarding rules, and all the port forwarding rules are rules that control how things are allowed to get to your network, or specific things inside of your network from the WAN. And as I said at the outset, normally what a router that implements NAT does is it doesn't allow anything from outside the network to initiate contact. The one place where that's different is if you have port forwarding. And a prime example of port forwarding, and something I've covered on my channel frequently, and something that also Brian covers on his awesome open source channel an awful lot, is the whole idea of using Nginx Proxy Manager, where what we do is we provide a port forward for both ports 443 and 80 that points to your Nginx Proxy Manager inside of your network. And so those connections are what allow the outside to get to the inside. And so self-hosters know all about those, the concept of NAT rules. I know that today's presentation has been a little bit on the long side and somewhat all over the place, but if you like this format, make sure and drop a message into the comments, as well as coming by chat.scotti-BYTE.com. And by the way, try to be good to the YouTube algorithm and do me a favor and subscribe and like to the channel, as well as hitting your notification bell so you can be aware of when the next presentation comes out. And that's it for today, and we'll see you next time.